Welcome to Tech with Koushik. This is set 2 of our AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 2. Review question number 45. Carefully. We are now working with content layout extraction. Consider the following scenario. A warehouse intake system receives scanned packing documents with dense tables, section headings, and QR codes. Downstream automation must retain structural layout information while also extracting the QR code values. The team wants a built-in Azure Content Understanding Analyzer that does not require a generative model deployment. Which analyzer is the best fit? Review each available choice. Choice A, pre-built document search. Choice B, pre-built layout. Choice C, pre-built document field schema. Choice D, pre-built read. In this case, select option B, pre-built layout. The reasoning is as follows. Pre-built layout is the content extraction analyzer intended for OCR plus rich layout, such as paragraphs, sections, and tables. Document analyzers support barcode/QR code extraction, and the pre-built content extraction analyzers do not require an LLM deployment. Now consider why the remaining options are unsuitable. A. Pre-built document search is optimized for our AG-ready search output, rather than the lowest level no LLM layout extraction requirement. C. A field schema utility does not replace the required OCR and document layout extraction pipeline. D. Pre-built read provides foundational OCR and barcode extraction, but does not provide the richer table and document structure analysis required here. The key takeaway is choose pre-built layout when document structure is decisive. Pre-built read is for foundational OCR without full layout analysis. Question number 46 highlights an important distinction. The central scenario is as follows. A retail creative agent generates new advertising scenes from customer-provided product photographs. The generated result must preserve distinctive visual details from the supplied product image as closely as the image generation API allows. Which request setting most directly increases fidelity to the input image? Focus on the distinction between these options. Option A, reduce the text generation temperature. Option B, set input_fidelity to high. Option C, enable a groundedness evaluator. Option D, send only a more detailed text description of the product. The appropriate choice is option B, set input_fidelity to high. For supported GPT image models, input_fidelity controls how strongly the image edit/generation process preserves style and features from supplied input images. Setting it to high increases that preservation effort. The incorrect choices fail for the following reasons. A. Temperature is not the image input preservation control used by GPT image editing. C. Groundedness evaluation assesses generated content. It does not increase visual similarity to an input image. D. A text description cannot preserve image-specific features as directly as using the supported input fidelity control with the source image. For GPT image input image preservation, distinguish input_fidelity from text sampling or post-generation evaluation controls. Let us examine question number 47. We are moving to indirect prompt attacks. Review the scenario carefully. A procurement agent receives third-party document text derived from user-uploaded screenshots. The content can contain hidden instructions that attempt to override the agent's intended behavior. The team wants malicious document content filtered and wants the model to treat external content as lower trust. Complete the document attack protection configuration. Review Statement 1. For prompt shields document attacks, set the action to the blank. Select from 1. Annotate, block, or disable the shield. Review Statement 2. For an additional lower trust treatment of third-party document content, the blank. Select from 2. Enable spotlighting, create a keyword block list, or increase OCR resolution. For Statement 1, select block. Block is required when detected indirect attacks must be prevented from reaching the model workflow. For Statement 2, select enable spotlighting. Spotlighting is specifically designed as an additional mitigation for untrusted document content. Exam tip. Prompt shields detect indirect document attacks. Spotlighting adds a lower trust treatment for document content when the supported API path allows it. Question number 48. A community support agent lets users attach photos. The application must classify visual content for harmful categories and stop images when configured severity thresholds are exceeded. Which safeguard should you implement? The options are: Option A, prompt shields for document attacks. Option B, image moderation. Option C, a custom text block list applied only to OCR output. Option D, keyword matching against image file names. The best answer is option B, image moderation. The requirement is satisfied because image moderation analyzes visual content for supported harmful content categories and can enforce configured severity-based blocking behavior. The remaining options are incorrect because A, prompt shields target prompt injection attacks, not general harmful image classification. C, a text block list sees only selected text strings and does not classify the image itself by harm severity. D, file names do not provide reliable visual content safety classification. A useful examination rule is this: use image moderation for harmful visual content. Use prompt shields for prompt injection attacks embedded in input or documents. Question number 49 requires careful analysis. This question moves us into document prompt shields. Analyze the scenario before evaluating the choices. A maintenance app performs OCR on uploaded equipment photos and appends the extracted text to the model prompt as supporting context. Because the images can come from external users, the OCR text may contain instructions planted by a third party. Which control should protect the model from those embedded instructions? Eliminate any option that fails a requirement. Consider option A, protected material text detection. Consider option B, prompt shields for user prompt attacks. Consider option C, image moderation. Consider option D, prompt shields for document attacks. The required response is option D, prompt shields for document attacks. The key reason is the OCR-derived text is third-party grounding content, so malicious embedded instructions are an indirect or document prompt attack. Prompt shields for documents target this attack class. The other choices do not satisfy the requirement because A, protected material detection addresses copyrighted/protected text, not instruction injection. B, user prompt shields target direct malicious user prompts, not instructions embedded in third-party context. C, image moderation classifies harmful visual content rather than indirect instructions passed to the language model. Remember this distinction for the exam. Direct malicious instructions from the user are user prompt attacks. Malicious instructions in retrieved or external content are document attacks. Apply precise reasoning to question number 50. Pay close attention to every stated constraint. A research assistant must ingest scanned reports containing tables, headings, and multi-column pages. Before the content is sent to downstream reasoning, the system must preserve document structure and produce markdown-oriented output. What should you configure as the document processing stage? Compare every choice before deciding. Next, option A, a generic chat completion request. Next, option B, an Azure Content Understanding Analyzer in Foundry tools. Next, option C, an Azure Language Text Analysis deployment. Next, option D, a raw multimodal responses API call with no document analyzer. The correct answer is option B, an Azure Content Understanding Analyzer in Foundry tools. This is correct because Azure Content Understanding document analyzers combine OCR and layout-aware extraction and can produce structured or markdown content suitable for downstream reasoning and retrieval. The alternatives can be eliminated because A, a chat completion does not provide the dedicated OCR and layout extraction pipeline required by the document structure. C, text analysis operates on text and does not provide the required scan document layout processing. D, a multimodal model can reason about images, but it is not the dedicated document analyzer for layout preserving markdown extraction. Keep this examination point in mind. Use content understanding when OCR, layout, tables, and our Azure or markdown document representations are part of the same extraction task. Let us work through question number 51. Let us first review the situation. An accounts payable application receives scanned invoices from many vendors. OCR alone often misidentifies totals because tables and page structure vary. The team needs OCR, layout analysis, and field extraction that generalizes across templates without training a custom machine learning model. Which service should the solution use? Compare the following options. Option A is Azure Content Understanding in Foundry Tools. Option B is Azure Language in Foundry Tools. Option C is a custom Azure machine learning model. The appropriate choice is Option A, Azure Content Understanding in Foundry Tools. Here is the technical justification. Content Understanding provides document OCR, layout-aware processing, and schema-based extraction suitable for varied document formats without requiring the team to train a custom ML model. B. Azure Language processes text semantics, but does not provide the required scan document OCR and layout extraction pipeline. C. A custom ML model adds training and operational effort that the requirement explicitly asks to avoid. The key takeaway is when the requirement combines OCR, layout, and configurable document extraction, Content Understanding is the Foundry-centered choice. Let us focus on question number 52. Next, we enter the topic of structure-aware ingestion. This scenario establishes the key requirement. An engineering knowledge base is built from scanned technical manuals containing headings and tables that can continue across pages. The existing ingestion path keeps only plain text, so retrieval loses table structure and source page information. The replacement ingestion must perform OCR, create structure-aware chunks, preserve headings, and attach page metadata. Which ingestion approach best matches those requirements? The relevant choices are as follows. Now examine choice A, basic parsing with fixed-size character chunks. Now examine choice B, one OCR result per page stored as a single unsplit chunk. Now examine choice C, advanced data parsing with structure-aware chunking and rich metadata. Now examine choice D, OCR followed only by fixed page-level chunking. In this case, select option C, advanced data parsing with structure-aware chunking and rich metadata. The reasoning is as follows. Advanced/high-fidelity data parsing is designed to preserve headings, tables, images, semantic structure, and page metadata while creating context-aware chunks, including support for complex multi-page tables. Now consider why the remaining options are unsuitable. A. Basic parsing loses the structure and rich metadata that the scenario explicitly requires. B. Treating each page as one chunk does not preserve logical structure or handle tables that span page boundaries well. D. Page-level chunking alone does not provide the requested semantic structure and table-aware processing. Use structure-aware or advanced parsing when our AG quality depends on tables, headings, semantic chunks, and source page metadata. We will now analyze question number 53. Begin by examining the scenario. A knowledge assistant indexes PDF manuals with Azure AI search. Important instructions can appear inside embedded diagrams, so the indexing pipeline must send those images to the built-in OCR skill. Search results must still retain metadata that can be used for source citations. How should the indexer prepare embedded images for the OCR skill? Now examine the possible answers. Choice A. Write the raw image bytes directly to a searchable string field by using output field mappings. Choice B. Configure the indexer to generate normalized images during document cracking. Choice C. Run the OCR skill against the document content text field. Choice D. Use only a shaper skill to create image objects after OCR has completed. The best answer is option B. Configure the indexer to generate normalized images during document cracking. Azure AI search image processing skills expect normalized images. Enabling image extraction/normalization in the indexer creates the normalized_images collection that OCR can consume. The incorrect choices fail for the following reasons. A. Output field mappings maps enrichment outputs to index fields. It does not perform the required image extraction and normalization. C. The OCR skill consumes image objects from normalized_images, not the document's plain content field. D. A shaper skill can restructure enriched data, but does not replace the indexer's image extraction step needed before OCR. Exam tip. For OCR on images embedded in PDFs, enable indexer image extraction so/document/normalized_images exists before the OCR skill runs. The next key item is question number 54. The focus now shifts to invoice understanding. Background. Alpine Outfitters uses Microsoft Foundry to build an agent platform for customer support and finance automation. Current environment. Finance staff manually compare supplier invoices with contract terms. The invoices contain tables, logos, and inconsistent page layouts. Business requirements. The review process must reduce manual effort while keeping invoice details available for verification. Technical requirements. The solution must analyze both textual content and visual/document layout, so extracted invoice information can be evaluated against contract requirements. Which Foundry capability should be used for the invoice review solution? Focus on the distinction between these options. Option A, image analysis only. Option B, Azure Content Understanding in Foundry tools. Option C, chat completions without a document analyzer. Option D, Azure Document Intelligence in Foundry tools. The correct answer is option B, Azure Content Understanding in Foundry tools. The requirement is satisfied because Content Understanding is designed to combine OCR/layout-aware document processing with structured extraction and downstream reasoning, which fits invoices with varied layouts that must be interpreted against contract information. The remaining options are incorrect because A, image analysis alone does not provide the full document layout and field extraction workflow required for complex invoices. C, a raw chat completion does not supply the dedicated document OCR/layout extraction pipeline. D, document intelligence is strong for structured document extraction, but the scenario requires the broader content understanding workflow for varied layout plus reasoning-oriented processing. A useful examination rule is this. Use content understanding when document extraction must preserve layout and feed richer reasoning or grounding workflows, not just return standard form fields. Let us work through question number 55. Begin by examining the scenario. A manufacturing support system uses Azure Content Understanding to analyze scanned maintenance guides. Extracted fields are stored for automation, but reviewers must be able to see where every field value came from in the PDF and route low confidence values to a manual queue. Which analyzer configuration should you enable? Choose from the following options. Option A is Enable Segment. Option B is Estimate Field Source and Confidence. Option C is Generative Extraction for every field with no confidence configuration. Option D is Labeled Samples Only. The required response is Option B, Estimate Field Source and Confidence. The key reason is Estimate Field Source and Confidence enables per-field confidence estimates and source grounding so extracted values can be validated against their locations in the source document. The other choices do not satisfy the requirement because segmentation controls how content is divided. It does not provide field-level confidence and source location by itself. C, Generative extraction does not automatically satisfy the explicit confidence and grounding requirement without the relevant setting. D, examples can improve extraction behavior, but labeled samples do not themselves enable the required confidence and source grounding output. Remember this distinction for the exam. For document field QA and human review, enable field source grounding and confidence. Segmentation solves a different problem. We will now analyze question number 56. Consider the following scenario. A contact center dashboard must display transcripts while customer calls are still in progress. Audio arrives continuously from the telephony platform, and supervisors need text within a few seconds rather than after the recording is complete. Which speech capability should process the audio? Choose from the following options. Choice A, batch transcription of completed recordings. Choice B, text-to-speech with a custom voice. Choice C, real-time speech-to-text over streaming audio. Choice D, speech translation solely to produce multilingual output. In this case, select option C, real-time speech-to-text over streaming audio. This is correct because real-time speech-to-text is designed to transcribe streaming audio with low enough latency for live call scenarios. The alternatives can be eliminated because A, batch transcription waits for files/jobs and is intended for non-real-time workloads. B, text-to-speech generates audio from text and does not transcribe incoming calls. D, speech translation is for translation scenarios and is not the direct requirement when live transcription in the source language is needed. Keep this examination point in mind. Streaming audio that must become text during the interaction calls for real-time speech to text, not batch transcription. Review question number 57. Carefully. We are moving to real-time voice agents. Let us first review the situation. A voice concierge agent must continuously receive streaming user audio, convert the speech into text for reasoning, and return spoken responses. The interaction must have very low latency and support turn-taking in which the agent can begin producing speech while incoming audio is still being handled. Which implementation provides the required speech-to-text and text-to-speech path? Now examine the possible answers. Option A is use real-time speech-to-text for incoming audio and text-to-speech for agent responses. Option B is use batch transcription and return only text responses. Option C is use an embeddings model to encode and decode audio. Option D is use speech translation as the only speech component. The appropriate choice is Option A. Use real-time speech-to-text for incoming audio and text-to-speech for agent responses. Here is the technical justification. Real-time speech-to-text processes the incoming audio stream for agent reasoning, and text-to-speech produces spoken agent responses with interactive latency. B. Batch transcription is not suitable for low-latency interactive turn-taking, and it omits spoken output. C. Embeddings do not perform speech recognition and speech synthesis. D. Speech translation does not replace the required reasoning input transcription plus text-to-speech response path. The key takeaway is real-time speech recognition plus text-to-speech provides the two required speech directions. Full duplex or interruptible turn-taking can also depend on the surrounding real-time session and voice activity orchestration. Proceed to question number 58. Consider this scenario. A live event application transcribes speakers and sends transcript segments to Azure Translator. Some individual segments contain both French and English. Translation quality drops when one segment mixes languages, but the application must translate all spoken content. What pre-processing should the application perform before translation? Choice A. Force French as the source language for every segment. Choice B. Use document translation on the entire live transcript as one file. Choice C. Split mixed language content into single language segments and translate each segment separately. Choice D. Rely on one automatic language detection result for the entire mixed language segment. The best answer is Option C. Split mixed language content into single language segments and translate each segment separately. The reasoning is as follows. Translator source language handling is more reliable when each input element is in a single language. Separating mixed language text lets each segment be detected or specified and translated independently. Now consider why the remaining options are unsuitable. A. A fixed source language causes content in the other language to be interpreted incorrectly. B. Document translation is not the appropriate pre-processing step for a live segment stream and does not solve intra-segment language mixing. D. Automatic detection generally identifies a source language for an input element. Mixed languages in one element can still lead to partial or incorrect translation. When one translation input mixes source languages, split by language first, language detection is most reliable on single language input units. The next item is question number 59. This is a harder question, so check every requirement carefully. Background. Woodgrove manufactures industrial equipment and uses a Microsoft Foundry support agent grounded in PDF product manuals stored in Azure Blob Storage. Current environment. The agent currently answers for model knowledge and does not use the detailed manuals. Business requirements. Support users must receive accurate answers grounded in the company's own product documentation. Technical requirements. The indexing pipeline must support vector retrieval over manageable document chunks so the agent can find relevant passages for natural language questions. Which two built-in Azure AI search skills should the indexing pipeline use? Select 2. More than one answer may be correct. Review the options. Option A. Key phrase extraction. Option B. Text split. Option C. Language detection. Option D. Azure OpenAI embedding. Option E. Entity recognition. Option F. Merge. Select Option B. Text split and Option D. Azure OpenAI embedding. Text split creates retrievable chunks, and Azure OpenAI embedding generates vectors for those chunks. Together, they provide the core enrichment needed for vector retrieval over the product documents. The incorrect choices fail for the following reasons. A. Key phrases can enrich text, but do not create the required chunk boundaries or vector representations. C. Language detection identifies language. It does not build the vectorized retrieval representation. E. Entity recognition extracts entities, but does not create chunk embeddings. F. Merge combines text fragments, commonly after OCR, but it is not one of the two core skills needed here for chunking plus vectorization. Exam tip. For integrated vector indexing, think in two stages. Chunk the content, then embed each chunk into the vector field. Let us examine question number 60. Background. Tailspin Toys is adding a Microsoft Foundry support agent for its product catalog. Current environment. Detailed product guides are stored as PDFs in Azure Blob Storage, but the agent currently answers only from its base model. Business requirements. Customers need grounded answers about only the company's products. Technical requirements. The product guides must be indexed for semantic and vector search, and the agent must retrieve relevant passages to answer natural language questions. Which service should be included so the agent can index and retrieve the product information for grounded responses? Review each available choice. Option A is Azure Translator in Foundry Tools. Option B is Azure AI Search. Option C is grounding with Bing Search. Option D is Azure Document Intelligence in Foundry Tools. The required response is Option B, Azure AI Search. The requirement is satisfied because Azure AI Search provides the indexing and semantic/vector retrieval capabilities needed to retrieve private product document content for our AG grounding. The remaining options are incorrect because A. Translator changes languages but does not index and retrieve the private product corpus. C. Bing grounding targets web content rather than the organization's blob-stored product manuals. D. Document intelligence can extract document content, but it is not the retrieval index required for semantic/vector or AG queries. A useful examination rule is this. Separate extraction from retrieval. Azure AI Search is the retrieval/index service for our AG, while document tools prepare content for indexing. We will now analyze question number 61. Next, we enter the topic of Custom Document Analyzer. Review the scenario carefully. A shipping company ingests scanned freight invoices with different table layouts. The application needs one reusable Azure Content Understanding Analyzer that returns structured JSON fields for invoice number, date, carrier, and total. Each field must also include a confidence value, so results below a review threshold can be escalated. What should you configure? Compare the following options. Choice A, a custom content understanding analyzer with a field schema for the required invoice values and confidence/source estimation enabled. Choice B, pre-built layout only, with no field schema. Choice C, a Foundry agent with groundedness guardrails and no document analyzer. Choice D, pre-built document search and Azure AI search.score as the field confidence. The correct answer is option A, a custom content understanding analyzer with a field schema for the required invoice values and confidence/source estimation enabled. The key reason is a custom content understanding analyzer can define the required structured fields and return confidence/source information for extracted values, enabling threshold-based human review. The other choices do not satisfy the requirement because B, pre-built layout extracts structure but does not define the requested business fields across templates. C, groundedness guardrails assess response grounding. They are not a document field extraction confidence mechanism. D, search.score ranks retrieval relevance and is not a confidence score for extracted invoice fields. Remember this distinction for the exam. Do not confuse extraction confidence with search relevance. Use analyzer field confidence for document review routing. Now consider question number 62. Scenario. A browser-based support assistant uses an Azure OpenAI GPT real-time model. The client must stream microphone audio to the model and play audio responses with the lowest practical interactive latency, targeting roughly 50 to 100 milliseconds transport latency. Which connection method should the client use? Available choices. Choice A, WebSocket. Choice B, RTMP. Choice C, WebRTC. Choice D, SIP. The best answer is option C, WebRTC. This is correct because for client-side web or mobile applications, WebRTC is the preferred real-time API transport for low-latency bidirectional audio and is documented as the lowest latency option. The alternatives can be eliminated because A. WebSockets are better suited to server-to-server scenarios and generally have higher latency than WebRTC for client audio. B. RTMP is a media streaming protocol, but is not a supported Azure OpenAI real-time API connection method for this scenario. D. SIP is intended primarily for telephony integration rather than a browser client's direct low-latency media path. Keep this examination point in mind. Use WebRTC for client-side real-time audio, WebSocket for server-to-server real-time integrations, and SIP for telephony. The next item is question number 63. The focus now shifts to private network isolation. Review the situation. A regulated claims agent runs in Microsoft Foundry. Only applications inside the company's virtual network may call the Foundry endpoint. The agent also accesses customer-owned Azure storage and Azure AI search, and outbound traffic to those resources must remain on private network paths. Complete the network design. For the first statement, restrict inbound access to the Foundry endpoint by using the blank. The options for this statement are 1. Public access from selected IP addresses, a private endpoint, or a service endpoint. For the second statement, for full outbound isolation while the company controls the network and routing, use the blank. The options for this statement are 2. Public egress, a bring your own virtual network, or a public NAT gateway. Statement 1 should be completed with a private endpoint. A private endpoint makes the Foundry endpoint reachable privately from the virtual network instead of relying on public inbound access. Statement 2 should be completed with a bring your own virtual network. A bring your own virtual network is the full isolation option when the customer must control IP ranges, peering, and routing. The key takeaway is treat inbound privacy and outbound isolation as separate network decisions. Proceed to question number 64. Consider this scenario. A subscription has 2 standard deployments of the same Azure OpenAI model in the same Azure region. The first deployment has an used token per minute capacity, while the second deployment is repeatedly throttled because its allocated TPM is too low. The subscription already has enough total quota for the model in that region. What should you do first? The options are: Option A, reallocate the model's available TPM quota between the deployments. Option B, increase max output tokens on every request to the throttled deployment. Option C, create a new conversation for every retry. Option D, enable persistent agent memory for the throttled deployment. In this case, select Option A, reallocate the model's available TPM quota between the deployments. Here is the technical justification. Azure model quota is allocated by subscription, region, model, and deployment type. If sufficient quota already exists, reallocating available TPM to the constrained deployment directly addresses the capacity problem. B. Increasing the possible output length can increase token demand and does not raise deployment quota. C. Changing conversation IDs does not change TPM allocation. D. Agent memory does not increase model quota or rate limits. Separate quota allocation from retry logic. Quota sets capacity. Backoff handles temporary throttling. Review question number 65. Carefully. This question moves us into search health monitoring. Begin by examining the scenario. A Foundry knowledge agent uses Azure AI search and application insights. Operations teams need the fastest signal for 3 different production problems. Match each problem to the capability you should inspect first. The items to be placed are: the first source item is nightly ingestion stopped, and the search index is stale. The second source item is search still returns documents, but result relevance has degraded. The third source item is request volume is unchanged, but generative AI cost increased sharply. The destination requirements are as follows. Destination A, indexer status and execution history. Destination B, search relevance evaluation and query testing. Destination C, token usage analytics. Destination D, image moderation metrics. The correct destination for nightly ingestion stopped and the search index is stale is indexer status and execution history. The correct destination for search still returns documents, but result relevance has degraded is search relevance evaluation and query testing. The correct destination for request volume is unchanged, But generative AI cost increased sharply is token usage analytics. The reasoning is as follows. Indexer status identifies ingestion failures, relevance testing evaluates retrieval quality, and token analytics explains model consumption changes. Exam tip. Monitor ingestion health, retrieval relevance, and model consumption as separate operational signals. Let us focus on question number 66. Focus on the following situation. A support agent has been in production for several months. The team wants to detect quality regressions after prompt, model, and retrieval changes. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. Evaluating representative production conversations or traces can reveal quality regressions that do not appear in latency metrics. Review statement 2. A latency increase by itself proves that the model's answer quality has drifted. Review statement 3. Safety signals should be monitored separately from groundedness and answer quality signals. The answer to statement 1 is yes. Production conversations and traces reflect real behavior and can be converted into evaluation data or evaluated directly. The answer to statement 2 is no. Latency is an operational metric. It does not by itself demonstrate semantic or quality drift. The answer to statement 3 is yes. Safety, groundedness, and quality measure different failure modes and should not be treated as interchangeable. A useful examination rule is this. Do not infer quality drift from operational metrics alone. Evaluate representative outputs. Question number 67. Next, we enter the topic of provenance auditing. Scenario. A regulated policy assistant uses retrieval-augmented generation. Auditors must be able to determine which retrieved evidence supported each final answer and correlate the answer with the execution that produced it. What information should the application retain? Review the options. Choice A. Only the final generated answer text. Choice B. Source identifiers or citations linked to the answer, together with trace or run correlation metadata. Choice C. Only the model deployment name and temperature value. Choice D. Only aggregate monthly token usage. The appropriate choice is option B, source identifiers or citations linked to the answer, together with trace or run correlation metadata. Provenance requires a durable relationship between generated output and the evidence and execution that produced it. Source identifiers or citations plus run or trace correlation support that audit trail. Now consider why the remaining options are unsuitable. A. The final answer alone does not show which evidence supported it. C. Model configuration is useful metadata but does not establish source provenance. D. Aggregate token usage is a cost signal, not an evidence trail. Remember this distinction for the exam. For auditability, preserve both source provenance and execution correlation. Now consider question number 68. Background. Contoso Bank is building a Microsoft Foundry agent that investigates account issues and can call a refund API. Current environment. The agent can safely retrieve balances and transaction history without human intervention. Business requirements. Routine investigation should remain automated, but a refund above $1,000 must never execute until an authorized employee approves it. Technical requirements. The solution should use a supported agent orchestration pattern and should pause before the sensitive action rather than review it only after execution. Which design best satisfies the requirement? Option A. Use a Foundry workflow with a human-in-the-loop approval step before the high-value refund tool executes. Option B. Allow the refund tool to execute automatically and send an approval notification afterward. Option C. Rely only on a system instruction that tells the model to ask for permission before large refunds. Option D. Run a nightly evaluator that flags large refunds after they have completed. The required response is Option A. Use a Foundry workflow with a human-in-the-loop approval step before the high-value refund tool executes. The requirement is satisfied because a human-in-the-loop workflow can pause execution and require approval before the sensitive tool action occurs, while leaving low-risk steps automated. The incorrect choices fail for the following reasons. B. Post-execution notification does not prevent an unauthorized refund. C. Prompt instructions alone do not provide an enforcement boundary for an irreversible tool action. D. Post-run evaluation detects behavior after the fact and cannot serve as pre-execution approval. Keep this examination point in mind. Use enforceable approval gates for sensitive side effects. Do not rely on prompting alone. The next item is question number 69. An enterprise will host agents in Microsoft Foundry. Conversation state, files, and vector stores must reside in resources owned by the enterprise. Clients must reach Foundry privately, and agent access to enterprise data must use private network paths. Which 3 design choices should you make? Select 3. Choose every option that satisfies the requirement. Available choices. Choice A. Use a standard agent setup with bring your own data resources such as Azure Storage, Azure AI Search, and Azure Cosmos DB. Choice B. Configure a private endpoint for inbound access to the Foundry endpoint. Choice C. Use a bring your own or managed virtual network for isolated agent egress to private resources. Choice D. Keep public networking enabled for all dependent resources and rely only on secret keys. Choice E. Use the basic agent setup because it provides the required bring your own private data plane. The required selections are Option A. Use a standard agent setup with bring your own data resources such as Azure Storage, Azure AI Search, and Azure Cosmos DB. Option B. Configure a private endpoint for inbound access to the Foundry endpoint. And Option C. Use a bring your own or managed virtual network for isolated agent egress to private resources. The key reason is standard setup supports customer-owned data resources. A private endpoint secures inbound access, and a virtual network isolation option is required when agent egress to dependent resources must stay private. The remaining options are incorrect because D. Public dependency access conflicts with the private network requirement, and secret keys do not provide network isolation. E. Basic setup is intended for simpler managed state scenarios and does not provide the required bring your own private data resource design. The key takeaway is private enterprise agents usually combine standard setup, private inbound access, and isolated egress. Question number 70. Review the situation. A Foundry prompt agent uses a custom function tool implemented by the application. The application must let the model request the function and then continue the response using the function result. Arrange the actions in the correct operational order. The sequence must use these items. Item 1. Execute the requested function and capture its result. Item 2. Define and register the function tool with its name, purpose, and parameter schema. Item 3. Submit the function call output back to the agent by using the matching call identifier. Item 4. Send the user prompt and receive the model's function call request. The correct sequence is as follows. The first item is define and register the function tool with its name, purpose, and parameter schema. The second item is send the user prompt and receive the model's function call request. The third item is execute the requested function and capture its result. The fourth item is submit the function call output back to the agent by using the matching call identifier. This is correct because the model can request only a function it knows about. The application then executes the requested function and returns the result associated with the function call so the agent can continue. Function calling is model request leads to application execution, leads to tool output, leads to continued model response. Let us work through question number 71. Review the scenario carefully. A developer assistant must generate functions, explain compiler errors, and refactor source code. The workload is dominated by programming tasks rather than image, speech, or embedding generation. Which model type is the best starting point? Compare the following options. Choice A, a code-oriented model. Choice B, an image generation model. Choice C, an embedding model. Choice D, a speech-to-text model. The correct answer is option A, a code-oriented model. Here is the technical justification. A code-oriented model is optimized for programming tasks such as code generation, repair, transformation, and technical reasoning over source code. The other choices do not satisfy the requirement because B, image generation models create visual content rather than source code. C, embedding models produce vector representations for retrieval and similarity tasks. D, speech-to-text models transcribe audio rather than perform code generation and refactoring. Exam tip. Choose models by task capability, not by size alone. Now consider question number 72. Scenario. An insurance intake application uses an LLM to interpret free-form claim descriptions. Policy eligibility, however, depends on deterministic business rules that must never be changed by model creativity. The final response should explain the decision in natural language. Which design best meets the requirement? Review the options. Option A. Let the LLM decide both eligibility and the explanation from the policy text. Option B. Use a rules engine for the eligibility decision and use the LLM to interpret inputs and explain the rule engine result. Option C. Increase temperature so the LLM explores more eligibility outcomes. Option D. Replace the rules with a vector search index and use the highest scoring document as the decision. The appropriate choice is option B. Use a rules engine for the eligibility decision and use the LLM to interpret inputs and explain the rule engine result. The reasoning is as follows. A hybrid design keeps deterministic policy enforcement in the rules engine while using the LLM for flexible language understanding and explanation. The alternatives can be eliminated because A. Allowing the LLM to own the final eligibility rule introduces non-deterministic policy behavior. C. Higher sampling variability makes deterministic enforcement less reliable. D. Retrieval finds relevant information but does not replace an explicit business rule decision. A useful examination rule is this. Keep hard business constraints deterministic. Use the LLM around them for language and reasoning. Proceed to question number 73. Consider this scenario. A semi-autonomous operations agent can investigate incidents, call diagnostic tools, and handwork to specialist agents. The team wants useful autonomy without allowing unbounded execution or uncontrolled irreversible actions. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Configure termination conditions or turn limits so autonomous execution cannot continue indefinitely. Statement 2. A system prompt that says be careful is an adequate enforcement control for every destructive tool. Statement 3. Require human approval before tools that perform sensitive or irreversible actions when the workflow policy demands oversight. Statement 1. The answer is yes. Bounded execution prevents runaway autonomous loops and is an important safeguard for semi-autonomous workflows. Statement 2. The answer is no. Prompt wording is not a reliable authorization boundary for destructive side effects. Statement 3. The answer is yes. Approval-required tools or human-in-the-loop workflow steps can enforce oversight before the action is performed. Remember this distinction for the exam. Autonomy should be bounded. Irreversible actions need stronger controls than instructions. The next item is question number 74. This question moves us into text-to-image generation. A marketing application must create a completely new product background illustration from a written creative brief. No source image is provided. Which implementation is most appropriate? Choice A. Send the brief to an image generation model using a text-to-image request. Choice B. Send the brief to an embedding model and render the return vector. Choice C. Use image captioning to create the illustration. Choice D. Use OCR to reconstruct the illustration from the prompt. The best answer is option A. Send the brief to an image generation model using a text-to-image request. Text-to-image generation is designed to synthesize a new image directly from a natural language prompt. B. Embeddings represent semantic meaning but do not render images. C. Captioning describes an existing image rather than generating a new one. D. OCR extracts text from images. It does not generate images from text. Keep this examination point in mind. Generation creates new media. Understanding features analyze media that already exists. Now consider question number 75. Review the situation. A creative application uses a Microsoft Foundry video generation model. One request starts from a written scene description only. Another starts from a reference image plus instructions for motion. Complete the generation mode choices. The first statement reads, for the prompt-only request, use the blank. The available choices are 1. Text-to-video generation, video segmentation, or speech-to-text. The second statement reads, for the reference image request, use the blank. The available choices are 2. Image-to-video generation, image captioning, or document OCR. The correct value for statement 1 is text-to-video generation. A written prompt without source media is a text-to-video generation scenario. The correct value for statement 2 is image-to-video generation. A reference image used to guide generated motion is an image-to-video generation scenario. The key takeaway is identify the input modality first, text, image, or an existing generated video. Let us examine question number 76. Consider the following scenario. A Sora 2 video has already completed successfully. The editor wants to change only the color palette while preserving as much of the original structure, motion, framing, and scene transitions as possible. What should the application do? Now examine the possible answers. Option A is create an unrelated new video from the revised prompt. Option B is use video remix with the completed video ID and a narrowly scoped updated prompt. Option C is extract all frames and run OCR on each frame. Option D is convert the video to an embedding and modify the vector values manually. In this case, select option B. Use video remix with the completed video ID and a narrowly scoped updated prompt. The requirement is satisfied because video remix is intended for targeted edits to an existing generated video while preserving its core structure and motion. Now consider why the remaining options are unsuitable. A. A new generation can change the entire composition and does not preserve the existing video structure. C. OCR does not edit video appearance. D. Embedding manipulation is not the supported video editing workflow. Use remix for targeted edits to an existing generated video instead of regenerating from scratch. Proceed to question number 77. We are moving to visual response tasks. Scenario. An accessibility and support application uses vision-capable models to respond differently depending on what the user needs from an image. Match each requirement to the most appropriate visual task. Review the items in the left column. Left item 1. Provide a short screen reader-friendly description of an image. Left item 2. Answer, which valve appears open, using evidence visible in the uploaded image. Left item 3. Provide a longer accessibility-oriented description with more visual detail. The right side choices are: right side entry A, alt text or concise image caption. Right side entry B, visual question answering. Right side entry C, extended image description. The correct pairings are: pair provide a short screen reader-friendly description of an image and alt text or concise image caption. Pair answer, which valve appears open, using evidence visible in the uploaded image and visual question answering. Pair provide a longer accessibility-oriented description with more visual detail and extended image description. The key reason is concise captions support alt text, visual question answering grounds an answer in image evidence, and extended descriptions provide richer accessibility context. Exam tip. Captioning describes the image, visual cue, and A answers a question about it. Extended descriptions add depth. Question number 78. A media archive uses Azure Content Understanding to process long training videos. The archive needs scene-level structure, searchable speech, and representative visuals. Match each requirement to the appropriate audio-visual analysis element. Review the available source items. Source item 1. Divide a long video into meaningful scene or topic sections. Source item 2. Capture spoken dialogue with timing and speaker information. Source item 3. Obtain representative visual frames from the video. Now review the available destinations. Target A, video segmentation. Target B, transcript phrases. Target C, keyframe extraction. Target D, text-to-image generation. For mapping 1, pair divide a long video into meaningful scene or topic sections with video segmentation. For mapping 2, pair capture spoken dialogue with timing and speaker information with transcript phrases. For mapping 3, pair obtain representative visual frames from the video with keyframe extraction. This is correct because content understanding can segment video, return time transcript phrases for audiovisual inputs, and extract key frames that represent video shots. A useful examination rule is this: for video understanding, separate temporal segmentation, speech transcription, and visual frame extraction. Now consider question number 79. The focus now shifts to visual policy controls. Consider this scenario. A brand governance pipeline reviews generated and uploaded marketing images. Company policy requires approved assets to carry a watermark, prohibits a defined set of symbols, and requires use of the official brand mark. Which 3 visual policy controls directly correspond to the requirements? Select 3. Identify all valid responses. The options are: Option A, apply the required watermark to approved visual output. Option B, detect or flag prohibited symbols. Option C, validate brand usage requirements for the official mark. Option D, increase model temperature to improve creative diversity. Option E, track only token usage for the image workflow. The choices that satisfy the requirement are Option A, apply the required watermark to approved visual output. Option B, detect or flag prohibited symbols. And Option C, validate brand usage requirements for the official mark. Here is the technical justification. Watermarking, prohibited symbol detection, and brand usage validation are direct visual policy enforcement controls. The incorrect choices fail for the following reasons. D, sampling diversity does not enforce visual policy. E, token usage is an operational metric and does not validate image content. Remember this distinction for the exam. Visual policy controls enforce what may appear in media, generation parameters, and cost metrics do not. Question number 80. Background. A manufacturing support application lets technicians upload photographs of damaged equipment and ask natural language troubleshooting questions. Current environment. The equipment types vary, and the company does not maintain a fixed object detection label set for every possible component. Business requirements. Technicians need answers that explain what the image shows and respond to ad hoc questions about visible damage. Technical requirements. The application must reason over both the uploaded image and the technician's text question without first training a custom vision classifier. Which approach should you use? Available choices. Choice A. Use a vision-enabled multimodal model with the image and question as inputs. Choice B. Use OC or only and answer from any text detected in the photograph. Choice C. Use an embedding model as the only model and return the nearest vector ID. Choice D. Use an image generation model to recreate the equipment and infer the damage from the new image. The correct answer is Option A. Use a vision-enabled multimodal model with the image and question as inputs. The reasoning is as follows. A vision-enabled multimodal model can analyze image content together with natural language instructions and answer questions grounded in the visible evidence. The remaining options are incorrect because B. OC or can recover text, but does not provide general visual reasoning over components and damage. C. Embeddings support similarity retrieval, but do not directly answer visual questions. D. Generating a replacement image can alter evidence and is not an analysis workflow. Keep this examination point in mind. Use multimodal understanding when the answer depends on both visual evidence and a natural language question. Review question number 81. Carefully. The focus now shifts to text analysis tasks. Let us first review the situation. A document processing service must apply several different text analysis operations to incoming support records. Match each requirement to the most appropriate capability. The left side items are: left side entry 1. Identify people, organizations, and locations in unstructured text. Left side entry 2. Extract the main concepts or talking points from a document. Left side entry 3. Produce a concise summary of a long text. Left side entry 4. Return generated fields that must conform to a defined JSON schema. The second set contains choice A on the right, named entity recognition. Choice B on the right, key phrase extraction. Choice C on the right, summarization. Choice D on the right, structured outputs with JSON schema. Here are the completed matches. Match identify people, organizations, and locations in unstructured text with named entity recognition. Match extract the main concepts or talking points from a document with key phrase extraction. Match produce a concise summary of a long text with summarization. Match return generated fields that must conform to a defined JSON schema with structured outputs with JSON schema. NER categorizes named entities. Key phrase extraction identifies main concepts. Summarization condenses text, and structured outputs enforce a supplied JSON schema for supported model/API combinations. The key takeaway is choose text capabilities by the required output: entities, concepts, summary, or schema-constrained JSON. Evaluate question number 82. Against every requirement. Identify the decisive requirement in this scenario. A customer feedback application processes free-form support comments. It must classify overall sentiment, identify personally identifiable information before storage, and assign each message to a custom tone label such as angry, apologetic, or formal. Select the appropriate text analysis approach for each requirement. Choose the correct entry for every drop-down field. Statement 1. For positive, neutral, or negative labels with confidence scores, use the blank. Choose between 1. Sentiment analysis, named entity recognition only, or vector search. Statement 2. For names, email addresses, and other personally identifiable information, use the blank. Choose between 2. PI detection, key phrase extraction, or image moderation. Statement 3. For the custom tone labels defined by the application, use the blank. Choose between 3. A generative classification prompt constrained to the required tone labels, token usage analytics, or speech synthesis. The answer to the first statement is sentiment analysis. Sentiment analysis returns positive, neutral, or negative sentiment with confidence scores. The answer to the second statement is PI detection. PI detection is designed to find sensitive personal identifiers in text. The answer to the third statement is a generative classification prompt constrained to the required tone labels. A constrained generative classification prompt can implement domain-specific tone labels that are not the same as standard sentiment categories. Sentiment, PI, and custom tone are different text analysis objectives. The next item is question number 83. Review the situation. A compliance application sends policy change notices to a supported Azure OpenAI model through the Responses API. Every response must contain exactly the field's obligation, owner, due_date, and severity with schema conformant types so downstream code can parse the result without repairing arbitrary JSON. What should you configure? Review the options. Option A, structured outputs with response format type JSON_schema and the required schema. Option B, plain text output with a prompt that says, try to use JSON. Option C, an embedding model with 4 vector dimensions. Option D, a higher temperature value, so all fields are more likely to appear. The required response is Option A, structured outputs with response format type JSON_schema and the required schema. The requirement is satisfied because structured outputs with a JSON schema constrain a supported model/API response to the defined object structure and required field types. The other choices do not satisfy the requirement because B, prompting for JSON alone does not guarantee schema conformance. C, embeddings produce vectors rather than structured business fields. D, temperature changes sampling variability and does not enforce a schema. Exam tip. Use structured outputs when downstream code requires schema guarantees, not merely valid-looking JSON. Proceed to question number 84. We are moving to audio reasoning. Consider this scenario. A maintenance application receives an audio recording that contains a technician speaking while an abnormal machine noise is audible in the background. The application must reason about both the spoken description and nonverbal audio characteristics rather than relying only on a transcript. Which model capability is required? The options are: Choice A, an audio-capable multimodal model that can reason over audio input. Choice B, speech-to-text as the only processing step. Choice C, text-to-speech as the only processing step. Choice D, a text embedding model. The correct answer is Option A, an audio-capable multimodal model that can reason over audio input. The key reason is when the decision depends on both speech and nonverbal acoustic information. The model must be able to consume and reason over audio rather than receiving only transcribed text. The alternatives can be eliminated because B, speech-to-text can lose nonverbal acoustic information that is relevant to the task. C, text-to-speech generates audio and does not analyze incoming audio. D, text embeddings do not perform multimodal audio reasoning. A useful examination rule is this: transcription converts speech to text. Audio reasoning uses the audio modality itself as evidence. Proceed to question number 85. Scenario. A live conference application must continuously translate streaming speech with minimal delay. Users need both translated speech and a translated transcript while the speaker is still talking. Which capability is the best fit? Available choices. Choice A, GPT real-time translate. Choice B, batch transcription followed by offline document translation. Choice C, text-to-speech without translation. Choice D, Azure AI search semantic ranking. The appropriate choice is option A, GPT Real-Time Translate. This is correct because GPT Real-Time Translate is designed for continuous low-latency audio translation and can produce translated speech and text as the stream progresses. B, a batch pipeline waits for completed content and does not meet the continuous low-latency requirement. C, text-to-speech synthesizes audio but does not translate the incoming stream. D, search ranking is unrelated to live speech translation. Remember this distinction for the exam. For continuous live translation, use a streaming translation capability rather than a batch pipeline. You have completed Set 2 of the AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.